Unfortunately, the last few minutes of the lecture 13, the video for that lecture were cut off, and so this is the end of that lecture. It's just going to be a brief description of this last problem, 6.4-2. So as was said at the very end of lecture 13.1, a transmitter with a real impedance of RT is connected to a lossless transmission line of real characteristic impedance R0, and then to an antenna of real input impedance R0. And what we want to do is to derive an expression for the transmit efficiency, which is defined as the power delivered to the antenna divided by the total power delivered by the transmitter. And we were at the very end of that lecture, we were discussing this statement: neglect any mismatch effects. We would not expect any reflection here at the end of the transmission line. Here's the transmission line, and here's the R0 for the antenna, the input impedance of the antenna. And since the input impedance of the antenna is the same as the characteristic impedance of the transmission line, we would not expect any mismatch there or any reflection. So let's now proceed to find this efficiency, the transmit efficiency. We'll call it E, and once again that is defined as the power delivered to the antenna here divided by the total power delivered by the transmitter, by this source right here. And so the current here is I, and of course then the power that is no power is being reflected here, so the power delivered to the antenna will be I squared R0, and the power burned up here in the transmitter is I squared RT. So that means then that the power delivered to the antenna is I squared R0, and the total power delivered by the transmitter is I squared R0, which is the power there, plus I squared RT, the power here. And so if we take this ratio, of course, hardly anything could be simpler. We just cancel out the I squared terms in both top and bottom, and we get an efficiency of R0 divided by RT plus R0. And that's really the end of that question of the text. But I put here a subsequent note, say, for what value of R0 with RT, we're considering RT to be fixed, does the maximum power transfer occur in this situation where the transmission line is lossless and mismatch effects can be ignored? So again, if we assume here that we're going to vary R0, but that means varying both the characteristic impedance of the transmission line and the input impedance of the antenna. So if we're free to vary R0, but we keep RT fixed, then we ask for what value of R0 does maximum power transfer occur? Well, this is essentially an identical problem to 6.4-1, and so using that same technique, you would find, of course, just as in 6.4-1, we found out that the maximum power transfer occurred for R sub L equals R sub A. Well, likewise here, we would conclude that the maximum power transfer in this case would occur for R0 equals RT. But interestingly, you might think that maximum power transfer would occur for a transmit efficiency of 100%, but no, actually R0 equals RT corresponds to an efficiency of 50%. So that's an interesting note, interesting observation to be aware of. So that concludes now lecture 13, and good luck.